Time is familiar to everyone, yet it's hard to define and understand. Science, philosophy, religion, and the arts have different definitions of time, but the system of measuring it is relatively consistent. Clocks are based on seconds, minutes, and hours. While the basis for these units has changed throughout history, they trace their roots back to ancient Sumeria. The modern international unit of time, the second, is defined by the electronic transition of the cesium atom. But what exactly is time? Scientific definition: physicists define time as the progression of events from the past to the present into the future. Basically, if a system is unchanging, it is timeless. Time can be considered to be the fourth dimension of reality, used to describe events in three-dimensional space. It is not something we can see, touch, or taste, but we can measure its passage. The arrow of time physics equations work equally well whether time is moving forward into the future, positive time, or backward into the past, negative time. However, time in the natural world has one direction, called the arrow of time. The question of why time is irreversible is one of the biggest unresolved questions in science. One explanation is that the natural world follows the laws of thermodynamics. The second law of thermodynamics states that within an isolated system, the entropy of the system remains constant or increases. If the universe is considered to be an isolated system, its entropy, degree of disorder, can never decrease. In other words, the universe cannot return to exactly the same state in which it was at an earlier point. Time cannot move backward. Time dilation. In classical mechanics, time is the same everywhere. Synchronized clocks remain in agreement. Yet we know from Einstein's special and general relativity that time is relative. It depends on the frame of reference of an observer. This can result in time dilation, where the time between events becomes longer, dilated, the closer one travels to the speed of light. Moving clocks run more slowly than stationary clocks, with the effect becoming more pronounced as the moving clock approaches light speed. Clocks in jets or in orbit record time more slowly than those on Earth. Muon particles decay more slowly when falling. And the Michelson-Morley experiment confirmed length contraction and time dilation. Time travel. Time travel means moving forward or backward to different points in time, much like you might move between different points in space. Jumping forward in time occurs in nature. Astronauts on the International Space Station jump forward in time when they return to Earth because of its slower movement relative to the station. The idea of traveling back in time, however, poses problems. One issue is causality, or cause and effect. Moving back in time could cause a temporal paradox. The grandfather paradox is a classic example. According to the paradox, if you travel back in time and kill your grandfather before your mother or father was born, you could prevent your own birth. Many physicists believe time travel to the past is impossible, but there are solutions to a temporal paradox, such as traveling between parallel universes or branch points. Time perception. The human brain is equipped to track time. The suprachiasmatic nuclei of the brain is the region responsible for daily or circadian rhythms, but neurotransmitters and drugs affect time perceptions. Chemicals that excite neurons so they fire more quickly than normal speed up time, while decreased neuron firing slows down time perception. Basically, when time seems to speed up, the brain distinguishes more events within an interval. In this respect, time truly does seem to fly when one is having fun. Time seems to slow down during emergencies or danger. Scientists at Baylor College of Medicine in Houston say the brain doesn't actually speed up, but the amygdala becomes more active. The amygdala is the region of the brain that makes memories. As more memories form, time seems drawn out. The same phenomenon explains why older people seem to perceive time as moving, but there isn't any radiation with earlier origins. One argument for the origin of time is that if it extended backward infinitely, the night sky would be filled with light from older stars. Will time end? The answer to this question is unknown. If the universe expands forever, time would continue. If a new Big Bang occurs, our timeline would end and a new one would begin. In particle physics experiments, random particles arise from a vacuum, so it doesn't seem likely the universe would become static or timeless. Only time will tell.